So this is the 8th session in signals and systems, and we are going to study a MATLAB function which will generate piecewise linear continuous time signals. Now in one of our earlier lectures we had studied this function. Only thing, it had one small error depending on the sampling time that we choose. So it could be as small as 0.1% or 0.01%, etc. But in this session we are going to study a modified function which will remove that error. Of course, the quantization error cannot be removed, it will always remain. Alright, so let us start. So piecewise linear continuous time function, the program for this we want to study. But before we study this program, we would like to see what is the kind of input we provide. So the inputs is endpoints of linear segments. So T array is provided. So -3 is the first point on the line, and the second point on the line corresponds to T equal to -1. And at -3 the sample value is 0, and at -1 it is equal to 1. So all the intermediate points will be calculated. So this is somewhat similar to what we did in the case of a discrete time function. Only difference is that there our independent variable was n, and these were all integer values. So the number of insertions that we had to do depended on how many total numbers we had here. If they were small, the number of insertions required were not very large. But when you are talking about continuous time function, if you take -3 and -1, in this range also you can have very large number of points, because your sampling time is going to be TS, which is going to be quite small compared with this total time segment. So that is one difference you should note. Otherwise, apart from that, the program for writing the function is very similar, but we'll point out the differences as we go through that function. Alright, so first line is represented by these 2 points, -3, 0, -1, 1. Then the second line, -1, 1, 1 and 1. Similarly the other lines. Note one thing, that the number of endpoints 1, 2, 3, 4, 5, 6. So if I have 6 number of endpoints, then the total number of lines that I'll get will be 1 less. That is because the first line requires 2 points. Thereafter, only 1 additional point is required. So that is why you will find that the total number of line segments that you will be generating will be 1 less than the endpoints which are provided here. Alright. So this is the kind of input that we will provide, and the intermediate points will be calculated by the function. So let us now see the program for the function. Again, this is similar. So input is t and x. In the case of discrete time function, this was n and x, and n was an integer. So it was an integer variable in MATLAB, whereas here this t is going to be a continuous or a floating point variable, since it's a continuous variable. So t and x are the inputs, and ty and y are the output. So t is an array, x is an array, ty is also an array, but the difference is that it will calculate all intermediate points. So it will hold large number of points, and same remark goes for y also. Alright. So what do we do now? We first find the total number of points that are provided in the input. So nt is equal to length of t. So if total number of points in this are 7, then nt will have a value which is equal to 7. Okay. Then you calculate the sampling time. This is something which was not required for the case of a discrete function, because for discrete function your independent variable n is an integer and your increment is always unity. Whereas in the case of a continuous variable, your increment should be as small as possible. So the question is, how small? So the answer to that is that we first calculate the total time length. What is the total time from the first value to the last value? So this difference will give you the total time, and we select ts, which is quite small compared with this total time. So in this case I have selected 1000 times as small. That is what I have selected. Alright. Then you initialize the output arrays. So ty is initialized to null, y is also initialized to null, and then you will get into the for loop. And every time the for loop is traversed, what it will do, it will calculate the slope for the line, it will calculate the intercept for the line, and then it will generate all intermediate points, and therefore will generate the array for ty and y for that particular line segment. So when in that for loop the index is incremented, it will do the same calculations for the second line and so on. So this is again very similar to what we did in the case of a discrete function, but let us look at the entire program. So for I equal to 1 to nt minus 1, remember we have said that the number of lines is going to be 1 less than the number of endpoints. That is why nt minus 1. And every time the for loop is traversed, one line segment is generated. Therefore, this will generate a total of 1 to nt minus 1 number of line segments. Okay, it will start from 1 and go up to this. That's what I mean. Alright, then you calculate t1, that is ti, x1, xi, t2, x2 as usual, and then calculate the slope, because once you know 2 points on the straight line, you can calculate the slope and you can calculate the intercept. Okay. Then what you do? Then you calculate the time array for that particular segment. So that segment starts from t1. Okay, that was obtained here, and then time increment of ts, sampling time ts, and goes up to t2. Note that this t1 and t2 will change every time you go through the for loop, because you are talking about a different line segment. Alright, first time you do it, of course, is the first line segment. Then using this ty1, you calculate the sample values by applying the straight line equation. And then, as discussed before, you would like to avoid the duplicates. So if I is equal greater than 1, then in this array, instead of starting from the first value, you start from the second value, so the duplicates can be avoided. And finally, you do the appending. So ty1 is appended to the previous value of ty. So first time you do it, ty is going to be null, so ty itself will get ty1. But thereafter, when you do the appending, all the equations for the various lines will get appended. Alright, so that is for ty vector. Similarly, you do for the y vector, sample values, and of course provide appropriate number of ends here. So that is how you write the piecewise linear function for continuous time signals. So we are now ready to study the calling program or the main program. So in the main program, what we do as usual, we clear the console, clear the variables, clear the figure, and then provide the time array, which essentially holds the endpoints for each line. So as we have seen, this contains 1, 2, 3, 4, 5 lines. Okay, and the endpoint for each. So you got total number of points equal to 6. 1, 2, 3, 4, 5, 6. This we have already discussed. And for each point on t vector, in t vector you have a corresponding sample value. So these are provided. So with these inputs, now you just call the function, provide these arrays as input, and it will generate this. We already seen how this is generated, and now all you have to do is to plot this. So all the rest of this is simply for plotting whatever details you require. So since it's a continuous variable, you are using plot and not stem. You are using plot here. Provide line width, grade on, and x label, etc. All these things we have discussed before. So I'll not spend much time on this. So when you execute this program, this is what you will get. So you can see between -3 and -1, -3 and -1, the line starts from 0 and goes to 1. So 0 and 1. And notice only these points were supplied by the input, but all the intermediate values are calculated by the function. Then from -1 to +1, it remains constant at 1. So from -1 to +1 remains constant. Then between 1 and 3, it goes from 1 to 0. So from 1 to 0. between 1 and 3. Then between 3 and 5 it goes from 0 to 3. So between 3 and 5 it goes from 0 to 3. And finally between 5 and 7 it goes from 3 to 0. So it generates these 1, 2, 3, 4, 5 line segments because there are 6 endpoints for the line. So this is just one example, but you can of course use this program for different kinds of piecewise linear signals. So let me just show you one more example before we end this session. So suppose our input arrays are like this: -3, -1, then 1, 3, 5, 7. So between -3 and -1 it remains at 0. Between -1 and +1 it increases linearly from 0 to 1. Between 1 and 3 it remains constant at 1. Then between 3 and 5 it decreases linearly from 1 to 0. And between 5 and 7 it remains 0. So in this case you will see the signal generated by the function like this. First this is all 0, -3 and -1. Then -1 to +1, it increases to 1, then it remains constant, decreases and remains at 0. So the advantage of this piecewise linear function is that you can generate all various kinds of signals which can be represented by the piecewise linear segments. And in many of the exercises in signals and systems books, you will find very often the small signals are taken to represent the various properties of signals, various operations on signals, system properties and so on. That is why this function is useful, and we will use it whenever we want to generate a signal in order to illustrate some theory from signals and systems. And that's all in this session.